Hello, it's Dr. Daystorms, and now we're starting Chapter 11. And to begin this chapter, we're going to discuss the states of matter, and we're going to focus particularly on what's called the condensed phases. So perhaps one of the more simple questions to ask would be, what makes a gas, a liquid, and a solid? In case you've forgotten, or just because maybe you want to hear some classy music, let's listen to Matter Chatter.
The stuff of life is matter. Now here's the scientific chatter. I'm gonna give it to you nice and straight. When it comes to matter, there are three states: solid or liquid or gas. Solids stay put in a single place. When put in something else, they keep their own shape. Your chair is a solid, and so is a box. Your shirt is a solid, and so are your socks. A table is a solid, and so is your phone. A cookie's a solid, and so is a stone. Can you...
Well, I won't put you through any more of the Matter Chatter, unless, of course, you want to go look it up yourself on YouTube. But it does lend to this idea that the only thing that changes between the states of matter and the fundamental difference actually has to do with the distance between the particles. So water molecules can exist in vapor, as water, or as gas is water vapor, the liquid water, and of course is crystalline ice. So what are the differences between these? And so on the simplest level, we can see that there's complete disorder with respect to a gas molecule. Most of it, as we were talking in the last chapter, consists of empty space whenever it goes in the vessel, and it will take up whatever the shape is of the vessel that it's in. There are particles tend to be far apart, and we talked about the kinetic theory of gases, and they can have complete freedom. There's diffusion throughout the container. Whereas when we discuss a liquids, there are disorder. The particles are relatively free to move around. However, they are definitely closer together than they are in the gas form. It will still take the shape of whatever container that it's in. Whereas a solid, in particular we're going to be focusing on crystalline solids, they are ordered. The particles are essentially in fixed positions, they're close together, and there's very, very slow diffusion throughout the solid. Since solid and liquid states are so close together, many times they're called the condensed phases of matter, whereas gas is easily compressed. Both the liquid and a solid is essentially incompressible. So the state of substances in at any particular temperature or pressure depends on two antagonistic entities. So these are two things that are going against each other. The first of these actually has to do with something that we've discussed in the last chapter, and that's the kinetic energy of the molecules. So there is a constant motion, or the within the gas, and there's also motion within the liquid. And it's not that a crystalline solid necessarily is a static situation. It's just that they have much less freedom for movement there. And then the second entity here has to do with the strength of the attractions between the particles. And you can even think of the strength of the attraction and the possible repulsions that occur between the particles within it. So if we look at the different characteristics of these states of matter, we have the gas. Once again, it assumes both the volume and the shape of the container. It is compressible. We can take that piston and force it down. It flows readily and it diffuses rapidly. Whereas with a liquid will take the shape of the container, but it doesn't expand to fill the entire container. Meaning, if you take a 100 milliliter beaker and you only add 50 milliliters of water, it will only fill it halfway full. It won't expand all the way to the 100 milliliter mark. It's virtually incompressible and it does flow readily. It does flow. There is movement throughout it. Whereas a solid will retain its own shape and volume. It's virtually incompressible. So in that sense, it's like a liquid. It does not flow, and diffusion within it occurs very, very slowly. Hopefully this has been just a brief introduction, or perhaps a review of the 3 states of matter, and we're going to then really focus on the types of attractions that occur between the particles in the next video. These are what we in class have been talking about as the intermolecular forces, because these are between different particles. Don't confuse this with intramolecular, which is within the same particle, which is like a covalent bond, but we're talking about intermolecular forces. So I'll see you in class.